Okay, your notes last night were about assessing normality. One thing I wanted to make sure to go over with you, because as I was working through some answer keys, I saw that this was an important concept to know, and it hadn't been discussed yet. So, is a normal distribution appropriate? So go ahead and add this to your 2.2C notes from last night. One skill that we need to know is a normal distribution appropriate? So this is when you're given a mean and a standard deviation, and you know something else about the data. So maybe you know that it's talking about grades, and the highest possible grade is 100. And there are people who got hundreds. So what you want to do is make sure that you can find if two standard deviations above or below. So we'll have a graph of our normal distribution curve with mean in the middle. And then you want to be able to go above and below by two standard deviations. So I wrote mean and then I put plus standard deviation plus two standard deviations. Then I went negative standard deviation, negative two standard deviations. Because everything under the curve adds up to 1. So if you can't even get to two standard deviations, think about our empirical rule. So our empirical rule says that between one standard deviation, it's 68% of the data. And then even out here to two standard deviations is 95% of the data. So if we cannot even get two standard deviations, which would account for a lot of the data, then a normal distribution is not appropriate. So if two standard deviations above and below are not possible, normal distribution is not appropriate. So that's the key takeaway on that. So an example would be, the mean of a homework assignment is 95. Standard deviation is 6. Highest possible for a grade is 100. So would normal distribution be appropriate? No. It's going to be skewed, isn't it? So that's why you want to make sure that it's appropriate or not. So that is all I wanted to remind you on that. So we're going to go to the previous section and do C, D, and E. I'm going to introduce what we need to know about using Desmos. So these go along with about the tennis player, Nadal. So what percent of Nadal's first serves are between 100 and 110? So you would draw your normal distribution. And label, bless you, standard deviation is 6, mean is 115. So writing that is part of writing or of the drawing. So make sure to include that. I would go ahead and include where the mean is. Okay, so it says we want to know the percent of serves between 100 and 110. So 100, let's say this is 100. And this is 110. So we would shade that area. So area under the curve is what we want to find, which will find us the percent of serves between those values. So in order to put in the calculator, which I'm going to show you how to do it into Desmos, we've got to find our z-scores. So let's go ahead and draw if this was a standardized normal. We have 0 in the middle. And I'm going to do this. It's in the same spot, just it's going to have different numbers. So we're going to call this Z1 and Z2. We have 2 Z-scores we need to find. So Z1, we've got to use the formula for Z. So it is the value minus the mean over standard deviation. So our value is 100 minus the mean over standard deviation. So I'm going to pull up Desmos. So you can use Desmos just like a calculator. So I'd do the divide. Then I would do 100 minus 115 over 6. So it's negative 2.5. And then define Z2, value minus 115 over standard deviation again. So this value is 110. It's 115 over 6. So I'm just going to go and change that. Negative 0.83. I'm going to go 2 decimal places. Okay, so we found our Z's. Doesn't give me much room here, but it'd be negative 2.5. Negative 2.5 and negative 0.833. So once you have that, let's just clear Desmos. And we want to use normal distribution. So there's a couple of different ways. Y'all should be doing this with me. So that you have the Desmos open. There's 2 different places that you will find normal distribution. So we'll go to functions. And we will go to inference or probability distributions. So we have different options. So this is normal distribution. So we're going to pick norm dist, that first one. And it has nothing in the parentheses, but see how it says mean equals 0, standard deviation equals 1. So we're just going to leave that just like it is. Let's click the little magnifying glass, zoom fit, and that creates our normal distribution. Click on cumulative probability. This is where it's going to do the work for us. Just like the calculator finds those values for us, Desmos can do that too. So look at all the options. So region is the first option. So inner, looks like that, outer, left, and right. So what are we going to pick for this problem? Inner. Okay, so right now it's sitting at -1 and +1, but we need to change it to our z's. So negative 2.5 and then negative 0.83. And so it shades it for us and in the spots that it is, and it also gives us a value. So whenever we did this using the calculator, we had to write inverse norm, we had to write lower, upper. Well, when you do that, all you have to do is write what we filled in, the blanks. So this is going to be all you need to write down. And that counts as your lower and upper bounds. And then also write what we got as our area or our probability. So writing that counts as showing your work. So then we would just need to answer the question. So it says, what percent of Nadal's first serves are between 100 and 110? So we would change this to a percent. And so that would be 19.7% of serves are between 110 and 110. I mean 100 and 110 miles per hour in pH. Okay, so how do you like that so far? Okay, what if I tell you we can make it even easier? Okay, so we're going to close that. We found our z-scores. You know how to find z-scores, right? We're not going to forget that. Don't forget that, because you're still going to have questions about that. But there is a shortcut way. So let's go to normal distribution again. So go to functions, go down to probability distribution, normal dist. And instead of it being blank right there, it automatically fills it in as 0 and 1. We're going to fill it in with what we found, the 115, or what we were given, comma 6. And then hit the magnifying glass. Make this not so large. Okay, there we go. And then hit cumulative probability. We still want inner, but instead of changing these and writing these in as z-scores, we can just put in the 100 and the 110. Isn't technology great? So this one says 0.196.
For the previous method, if you put like 0.833.
Yes. Then it goes to it, right? Let me see if I can pull that back up. Got to go back a little bit. Okay, so if I put, add an extra 3 on there, there it goes, yeah. So it all depends on the rounding. Okay, so this one is, and here's another way to get to it. I think there's a few different ways. You can type it in normal dish, but let me just show you the other one. You don't have to do it, but you go to plus, you click inference, you choose probability distribution. And then you do your mean and your standard deviation. And that creates it. And then we did the 100 to 110. Okay, there we go. So it comes out to be the same answer. The second way that we did it didn't require us to change to z-scores. So whenever you want to know what do you need to write down for showing your work, you need to write down that line right there in purple. And I'm going to go ahead and change that to a 6 because of rounding. But it's not going to hurt if we do it a different way. Like if you put it as 6 instead. There we go. Because you could also put the 3 there. The other way, since we didn't change it to z-scores, you could have written it like this. Probability 100 less than or equal to x less than or equal to 110 equals the 0.196. And that would work. You don't have to do it both ways. This would suffice, as well as the drawing. And you only need one of the drawings at this point because we didn't change it to z-scores. So you would just need this first drawing right here. So that would be considered showing your work. Okay. All right, let's look at a different kind of problem, dealing with the same thing though. So keep Desmos open, don't delete it. It says the fastest 30% of Nadal's first serves go at least what speed? So let's go ahead and draw our normal distribution. Go ahead and title it, normal, or label it, 115.6. And then we would go ahead and put the 115. So the fastest 30%, where is that going to be found? On the left side or right side? Right. So we can shade. And then go ahead and write. I think it's actually a little bit more. Because think about 50% would be half. So I think that would actually be better to write it like that. Okay, so when we did this in the calculator, we did inverse norm. And we had to change it to Z, which actually with the calculator, you don't have to change them to Z-scores. You can input them in as your mean and your standard deviation also. So we're going to go back here. I am going to get rid of that one and only have, hopefully this is the same one you have. Okay, so this was from the last problem. We want it on the right side. It says compute. So compute is your probability or your area. This time we're given area and we're asked to find the bounds or the values. So click on bounds. So we're switching up what we're asking. And now it says, or now it allows you to change the area. So that value, we want to change that value to 0.3. So what I did was I made sure it was right. And then I changed compute. I'm not computing the area anymore. They gave me area, so I'm computing bounds. So then that allows me to change that right there. So the 0.30 or 0.3. So then it gives you the value now, 118.1. And if you click on it, it'll give you more decimal places. So if you were told to round to a certain number, you could. So we would answer this question. Let me do this. As we've got to write stuff down. We can't just write the answer. We got to show our work. So then the fastest 30% of serves go at least what speed? 118.1. So the fastest %30 of first serves go at least 118.1 miles per hour. All right. Hopefully you like Desmos. Makes it where you don't have to write as much too. All right, let's look at E. A different player has a standard deviation of 8 miles per hour on his first serves, and 20% of his serves go less than 100 miles per hour. If the distribution of his first serves is approximately normal, what is his average first serve speed? So with these word problems, draw your normal distribution. And so it's a totally different player. What do we know? We know it's normal. What else do we know? Standard deviation is 8, but we don't know the mean. So I'm going to do it like this. Okay, what else do we know?
20% go less than 100 miles per hour.
Yeah. So 20%. So is that going to be on the left side or right tail? Left. So we'll shade. It's going to shade all the way out, right? So it says 20% is that area. And do we know the value of the 20%? Yeah. Okay, so this one, we have to find what mean is. So we're gonna have to do a little bit more work than just putting it into the calculator. Guess we could try different numbers, but they're gonna require us to show some kind of work. So let's go ahead and standardize it. So standardizing it would look like this. Still the 20%. But when you standardize it, we do get 0 and 1. So knowing that information, we can find out what this is. And then that's going to help us find our mean. So let's go to Desmos and use that purple drawing there. Okay, so just take these off. Once you take it off, if you leave it blank, it automatically puts it at mean is 0, standard deviation is 1. Okay, we want, what is my region? What did I shade? Left. And then, are we computing area or bounds? Bounds. So we would change our value to 0.2. And so we just found the z-score. So this z is negative 0.842. Okay, so let's think about all the formulas that we have. How can we find the mean if we're given the z and standard deviation? Do we have a formula that uses those? Think back. Remember, the z is value minus mean over standard deviation. So we're going to have to use some algebra. We're going to plug in what we know. So negative 0.842 equals, do we have the value that z is? 100. Minus the mean. Do we have the mean? Nope. Do we have the SD? Yeah. Okay, so do the algebra to solve this out. Okay, we can't leave it as negative mu, so our mean is 106.7 miles per hour. Miles per hour. So then you would just want to make sure that it makes sense. If the distribution of his speeds is approximately normal, what is his average first serve speed? His first serve speed is 100. His average first serve speed, a lot of S's there, 106.7 miles per hour.